All right, so in this notes video, I'm going to go over what it means to be symmetrical and skewed. So when you're making a dot plot or a histogram, it can be a symmetrical shape, which means that the center of your data is basically very balanced right in the middle. So you'll notice that this looks very much like a little bell. Okay, the middle of our data is the highest, and then the points are very balanced on either side of our data. Okay. Or your data can be what is called skewed. Okay. Skewed is when one side of the data is a lot higher than the other side of the data. So when this happens, it's going to look kind of like a little building that is shifted with one side really high and one side really low. So if you look at this data right here in the middle, you'll see that this stack is really high, and then the stacks get progressively smaller, right? All the way down to this stack way down here. I like to think of it as like a little animal. So this is like the head of my little animal, right? Here's his little face, right? He's got little ears right here. It's like a little cat. Okay, and then here is like his body getting smaller, right? This would be like his little tail, okay? Where the tail is at, that is where we call the skew. So this guy would be skew left because the tail is on the left-hand side. Okay, compared to the far right picture we have here, this would be the little head of my animal again, right? And then the body going this way, and then the little tail, right here's its little legs, okay? The little tail of my little animal going like such, like a little chameleon, I guess is a better word than a cat. Okay, so this guy would be a skew right, okay? So how the data works, if your data is balanced, okay, like this guy, then the mean and the median are basically going to be in the exact same point, right? Because the median is the middle. Okay, if all the data points are balanced, then the mean and the median are going to be right there in the center. But when the data is skewed, right, does it make sense that the mean and the median are not going to be in the same points? Okay, they're going to be off because the data is skewed. So when you're looking at skewed data, doesn't matter which way it's skewed, okay, the mean will not equal the median because you're going to be pushed to one side or the other side, okay, so that data is not going to be balanced, okay? But when it's a balanced data, okay, so when it's symmetrical, okay, so when it looks something like this, nice pretty bell curve, the mean and the median are going to be right here in the middle of your data. Okay, which makes a lot more sense because they're going to be nice and balanced. So I'm going to make two different ones here for you, and we're going to look at what they look like and kind of find the mean and the median for both. So we're going to make a dot plot for this guy. Okay, so for our dot plot, okay, you can see this guy, we have zeros. We have 1, 2, 3, 4. So we have 1, 2, 3, 4. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 ones. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 ones. We have 1, 2, 3, 4 twos. We have 2 threes. We have 1 4. We have 2 5s. We have 2 6s. We have 1 7, 1 8, 1 9, 1 10, and 1 12. Okay, so hopefully this makes sense that this data, okay, is definitely what we're going to call as skew to the right, because my little head of my cat would be like right here. Okay, there's my little tail. Okay, so this is a skew right. Okay, so if we want to calculate the mean and the median, okay, for this data set, these two numbers should not be the same. Okay, so the mean and the median should not be the same because the data set is not balanced. Okay, so let's calculate that. So the mean, we got to add them all up and then divide by how many we have. Okay, so we're going to add up all of these numbers right now. So I'm going to do that here very quickly. So I've got to add up 1, 2, 3, 4 zeros. Okay, then I've got to add up 10 ones. And then 1, 2, 3, 4 twos. Excuse me while I type this all in. I've got 2 3s. I've got 1 4. I've got 2 5s, 2 6s, 1 7, 1 8, 1 9, and 110 and 112. And then I'm going to divide by how many I have, which is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 times 2 would be 30. So if I divide it by 30, my mean is going to be 3.2. Okay. My median is going to be my middle number, which is halfway. So this is nice because they're right in order. So halfway will be right here. So my median is going to be 2. Okay. So those two things are not equal. Okay. So in this case, it says, what do you think is a typical number of pets? Okay. Typical is going to usually be what occurs the most, right? The most often, the mode. What is the most typical number you see? So probably 1. Okay. Some people like to use the middle number for that, but 2 here is not a great representation, right? There's only 1, 2, 3, 4 2s, right? And we have 10 people that have 1 as their pet, right? So the mode would be a typical number for the number of pets that we have here. Definitely wouldn't want to use 3.2 because you can't have 3.2 pets, right? Okay, so that's how you do with a dot plot. Okay. If we come over here to a histogram, right? A histogram is a similar data source, except for now you've got to put everything into groups. Okay. So my first group you can see down here is going from 0 to 5. Okay. So from 0 to 5, we have this whole chunk of people. So we've got 1, 2, 3, 4, 5, 6, 7 people in this range. So we're going to come up to here. And we're going to draw our bar at 7. So there's 7 folks in this bar right here. Okay. Then from 6 to 10, we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 people in this bar. So we're going to come all the way up here to 13. Okay, so there's 13 people in that bar. Okay. From 11 to 15, there's actually no people because it jumps to 16. Okay, from 16 to 20, we have 2 people, so pretty small little bar here. Okay, and then from 22 to 25, we would have 3 people, right? So we would have 3 things in that bar. Okay, so what would we call this one? Symmetrical or skewed? It's not a great graph of either. I would probably still say it's a skewed graph to the right because it's a very tiny bars over here, and these 2 bars are both pretty big. We could kind of decide if we found our mean and our median. So let's find our mean and our median and see how close they are, and then kind of make a decision. So let's add these guys up, right? So we've got 3 plus 3 plus 1, 2, oops, so sorry. We've got 1, 2, 3, 4 4s. We've got 1, 5. We've got 1, 2, 3, 4, 5, 6, 7 6s. We've got 1, 2, 3, 4, 5, 6 7s. We've got a 16, a 17, 22, 22, and 25. And we're dividing this by the 25 people that are attending. So my mean is 8.52. My median is my middle number, and there are in order, so we got to count halfway would be 12, right in between 12 and 13. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. There's my 12th number, so my median is 6. So those numbers are not equal, so I would say this is definitely a skewed data set. Okay, typical age though here, right? 6 is a great choice because we've got 6. We have a lot of people that have that age of 6, so my median is a good representation of that typical age. Okay. I really like this last question, right? What event do you think these 25 people were attending, right? We got a lot of 3, 4, 5, 6, 7-year-olds, and then a few adults, a couple teenagers. Maybe a birthday party would be a great idea, right? You're at like Chuck E. Cheese or Scene 75 where you got a lot of kids and then a couple teenagers, older siblings maybe in there hanging out, and then some kind of workers that are helping out, 22, 22, 25. Could be a parent. Young parents, who knows? Okay, so a birthday party would be a good representation. Okay, so hopefully you see that since these data sets are skewed, right, that these are not going to have equal means and medians. That's what that important takeaway is for today. Okay, if you have any questions, please let me know.